in Millikan's oil drop experiment. So if you have not heard of this, it's okay, no problem. We have to focus on the concept. A charged oil drop of mass. What is the mass of this oil drop? 3.2 into 10 to the power minus 14 kg. Great. Is held stationary between the two parallel plates. Okay. So two parallel plates, which are distance between the plates is 6 millimeters. So I am converting here itself into meters. Okay, apart. By applying a potential difference of voltage, here is 1200 volt between them. How many electrons does the oil drop carries? Take the value of G is 10 meter per second square. So in case if you have not understood what is the problem, the question here says that you have two plates. Let's say these are two metallic plates, okay, and you have connected to the battery here. You have connected to a battery. What's the voltage of this battery? 1200. And you have taken an oil drop, small oil drop here. Now this oil drop is not falling down. Why it is not falling down? It is not falling down because the force of gravity that is equated by the force acting on this drop because of these two plates. Let me repeat. The gravity is making this drop to go down, but it is not going down, which means something is there equal and opposite, which is trying to keep it stationary over there. So here the force of gravity will be Fg, that must be equals to Coulomb's electrostatic force. So Fg will be mg, weight, and Fe, electrostatic force, is K, the charge of the first one, charge of the second one, upon the separation r square. We will talk about this thing. But sir, what is the charge of the first one? We don't know. What's the charge of the second one? We don't know here. Okay. So what we will do here is we will modify our Coulomb's law, okay, in terms of electric field. How? We know that electric force can also be expressed as charge into electric field. What is the charge carried by this drop? And what is the electric field in this region? Sir, how will you calculate the electric field? We know that the electric field E is equals to V upon D. What is V? V here is potential, 1200 volt, divided by the separation, that is 6 into 10 raised to minus 3. That will give us the electric field. So how much you will get here? 2 into 10 to the power 5. 2 zeros and 3 here. 2 into 10 to the power 5 Newton per Coulomb. That's our electric field. Okay, great. What we have to find? How many number of electrons? So be very careful. You don't have to find the charge. You have to find the number of electrons in this case. So first let's take E on the left hand side and we will write mg upon E. And the charge from the first formula of class 12th, charge is nothing but number of electrons times the electronic charge, and E equals to mg upon E. And let's take this E also on the left and right hand side. So this implies N is equals to mg upon EE. Now what is E? I hope by now you should know, all of you. E is 1.6 into 10 raised to minus 90, the charge of a single electron. So what's our mass here? Mass here is given as 3.2 into 10 raised to minus 14. Acceleration due to gravity, it's already given in the question to take 10 meter per second square. The electric field 2 into 10 to the power 5, and electronic charge 1.6 into 10 raised to minus 90. Let's simplify and check what we get the number of electrons. So first of all, if you multiply this 2 with 1.6, that will be 3.2. So it will cancel out this 3.2. Okay. Let's see now what we left with. So let me solve this part here. So N we left with here with 10 to the power minus 14 and 10. 10 to the power minus 13 in the numerator. And denominator it will be 10 to the power 19 and 5. That will be how much? Minus 14. So when 10 to the power minus 14 goes up, it will multiply and you left with N equal to 10. That is option D.